Hello and welcome everyone to our weekly session titled Latest in Bitcoin Tech, where we go through the Bitcoin Optech newsletter. And this week we will go through newsletter number 326, published 2 days ago on October 25th, 2024. And this week's newsletter contains of the news section as every week, and we have a weekly recurring section which is a selected Q&A from Bitcoin Stack Exchange. And then we have notable code and documentation changes, releases and release candidates. There are two news articles, one of which I will go through, and for the other, Anmol will be joining us, Anmol Sharma. So I will commence, and let's go through the preface. This week's newsletter summarizes updates to a proposal for a new LN channel announcements and describes a bid for sending silent payments with PSBTs. Also included are our regular sections with popular questions and answers from the Bitcoin Stack Exchange, announcements of new releases and release candidates, and descriptions of notable changes to popular Bitcoin infrastructure. I believe it was last week where we discussed about the Lightning Network, that a summit happened between Lightning developers in Tokyo, Japan, I believe, where a lot of ideas were exchanged about how the Lightning Network should go forward. And this is like a sequel to what we did or what we covered last week. So let's read this first news article. Updates to the version 1.75 channel announcements proposal. L. Moulton posted to Delving Bitcoin a description of several proposed changes to the new channel announcements protocol that will support advertising in simple taproot channels. The most significant planned change is to allow the messages to also announce current style P2WSH channels. This will allow nodes to later start switching off the legacy protocol when most of the network seems to have upgraded. Okay, so first let's understand what are these new channel announcements that are being talked about. Okay, channel announcements are advertisements that the channel is available to forward payments. Advertisements are relayed through the networks. So whenever two parties set up a Lightning channel, they have the option to either keep that channel private or they can make it public. If it's private, then the entire network is not aware of it. Okay, it is not a part of the channel graph. Okay, so there's this thing called as a channel graph. Just like we have a map, like all of us have at some point in time used the Google map where we have the addresses and the locations and the directions of the entire city. So we have something similar, an analogous known as the Lightning channel graph, which is an overview of all the Lightning channels that are connected to each other. So if you want to open a Lightning channel with someone, you have two options. You can either make it public or private. If you make it private, you don't announce it to the network, and thereby it is not a part of the overall Lightning channel graph. If you want to make it public, that is, you want people to route payments through your channel, then you can announce it and you make it public, and then it becomes a part of the Lightning channel graph. All right. So when two nodes establish a connection with each other on the Lightning network, and they establish a channel, they create a channel, they broadcast something which is known as a channel announcement message to let the entire network know that hey, we have created a channel and this is a public channel and it's open for routing payments. Many other nodes choose to announce their existence and their channels to encourage other nodes to use them for routing payments. Other nodes choose to remain private using unannounced channels. All right. So when you announce your channel, one incentive is that you can route payments through your channel and thereby receive fee. All right. So if your channel is a public channel, people can access it to route payments, and when they access your channel to route payments, you get paid fee. And if it's private, then it is not part of the channel graph. So nobody routes payments through your node except with those people with whom you have a direct channel established. Okay. As of this writing, many developers call the currently deployed Gold 7 announcement protocol Gossip V1. One key feature of Gossip V1 is that channel announcements and updates must be signed by a key belonging to a P2WSH UTXO corresponding to a 2 multi-sig script, the type of script used for V1 LN funding transaction. This means that a channel announcement or update message can only be created after someone has paid the on-chain fees necessary to get the P2WSH output confirmed, proving built-in denial of service, DOS protection against fake channel announcements that would waste bandwidth and potentially result in failed routing attempts across non-existing channels. So currently, there are certain specifications particular or to channel announcements, right? Like we have standardizations on layer one as well, right? We have digital signatures that are standardized, DER encoded signatures. We have public keys that are standardized, right? Because in a decentralized network, when you relay information in a standard format, it becomes easy for different clients to communicate with each other. So even on the Lightning Network, we have specifications known as bolts that standardize the relay of information over the Lightning Network. So the mechanism that is used for channel announcements currently is referred to as Gossip V1 version 1. Okay. Now, what is something noteworthy about this announcement mechanism, Gossip V1, is that when you announce a channel, okay, you have to broadcast a message to the Lightning Network saying that you have a channel which is public and people can use it to route payments. Okay. Now, the catch here is that that announcement message needs to be signed. That announcement message needs to be signed using a private key. And that private key should correspond to a public key, okay, that belongs to a P2WSH UTXO corresponding to a 2 of 2 multi-sig script. So those of you who are familiar with how the Lightning Network works, and we've talked about this in detail in the preceding sessions, that you have two transactions that happen on the mainnet. Okay, one is known as the funding transaction, and the other is known as the commitment transaction. Okay, so with the funding transaction, you initiate a Lightning channel and you make transactions on layer two. And once you are done, you are not in need of that Lightning channel anymore. You want to settle the balances on the mainnet. Then you go on the mainnet with what is known as a commitment transaction. Okay, as of now, Lightning channels can happen between two parties. Okay, and the commitment transaction and the funding transaction are both 2 of 2 multi-sig. Okay, so if there's a Lightning channel between Alice and Bob, they will have to establish a 2 of 2 multi-sig account to fund their Lightning channel. And the UTXOs for funding the Lightning channels and also the commitment transaction have to be P2WSH, right? They have to be P2WSH, pay to witness script hash. Okay. Now, one catch with this is that it becomes it basically compromises user privacy. How does it compromise user privacy? Because people who observe or monitor the blockchain can figure out with a certain pattern that a certain transaction belongs to a Lightning channel. How is that? Whenever on the blockchain you see a transaction which is 2 of 2 multi-sig script, okay, and it is P2WSH, that is a very strong hint that this is a commitment transaction for the Lightning Network, or it is a funding transaction for the Lightning Network. Because currently, Gossip V1, okay, currently the Lightning channels can only be established with a 2 of 2 multi-sig account, and that too P2WSH UTXO. So it becomes slightly easier for people to gauge that this transaction. So if you're looking at the blockchain and you see a transaction that comes from a 2 of 2 multi-sig account, and that has a P2WSH UTXO, it is a very strong hint that this is either a funded transaction for the Lightning channel or it is a commitment transaction or for the Lightning channel. And generally in Bitcoin, we always try to ensure user privacy by revealing as little information as possible. All right. So this is how it happens right now. Okay. So like this is like a compromise to user privacy. However, why is this important? This is important because it prevents DOS attacks. Okay, because now to make a channel announcement, you need to have a P2SH UTXO, right? You need to have some funds, right? You cannot make a channel announcement for free. You need to have a P2WSH UTXO and a 2 of 2 multi-sig account. So there is a cost that you will have to incur to make a channel announcement message. If we don't make people incur a cost for making channel announcement messages, what can happen? Okay, this is denial of service attack, because like people can announce fake channels, right? People can announce fake channels and they can announce hundreds and hundreds of these fake messages, and the nodes on the Lightning Network will try to process those messages, and they might get overburdened by the data that they have to pass, and the nodes might crash. Okay, so to prevent that denial of service attack, it is essential that to make a channel announcement message, you need to have a P2WSH UTXO in your 2 of 2 multi-sig account, and you have to use private key of that P2WSH UTXO to sign your channel announcement message. So this is how the channel announcement messages happen right now, and they're referred to as gossip leads. Okay. Now this approach has two major downsides. It restricts upgrades. The requirement in leaving gossip to use P2WSH UTXOs with a specific script prevents announced ML channels from using alternative scripts and output types. Anyone experimenting with new ideas for LL, such as simple tactile channels, is forced to use unannounced channels. Okay. So if you want to establish a channel in the Lightning Network, public channel, okay, you need to have a P2WSH script. Okay. Now what that does is that if somebody is experimenting with simple taproot channels, I'm sure most of you are aware that P2PR is being worked on. So it's in the pipeline to facilitate P2PR transactions on the Lightning Network, which currently is not possible. Now, if somebody wants to establish a Lightning channel with a P2PR transaction, they cannot announce that channel. Okay, they cannot announce that channel because for channel announcement, you need a P2WSH UTX. So they will have to keep it private. Okay, this is one drawback that if you want to announce a channel currently, you need to have a P2WSH UTXO in your 2 of 2 multi-sig account. You cannot have any other script or any other type of transaction. Linkability. It's expected that channels will be announced using a specific UTXO that is jointly controlled by the two nodes. Although this provides DOS protection through an efficient reuse of something the nodes already needs to pay for, it reduces privacy by publicly linking node and channel activity to a specific UTXO, right? So it basically it enables linkability, meaning it links a transaction on the mainnet with its use, right? Generally, we don't want people who are observing or monitoring the blockchain to get any information about the transaction. But what this does is that because you are restricted to a P2WSH output in a 2 of 2 multi-sig account, somebody who is monitoring the blockchain, people who are into blockchain heuristics, they can observe this pattern that wherever they see a P2WSH UTXO being spent from a 2 of 2 multi-sig account, it is a very high possibility that this is either funding a Lightning channel or it is a commitment transaction that is closing a Lightning channel. We ideally don't want that to happen. We don't want people to link UTXOs with their use cases or the identities of the spenders. So the current gossip V1 on the Lightning Network of channel announcement has these drawbacks. First drawback is that it restricts you to P2WSH scripts, and second is the linkability. It basically kind of leaks out some information about the use case of that transaction. A proposed upgrade to Ellen Gossip, sometimes called version 1.5 Gossip, would allow using P2TR outputs with key part signed channel announcements and updates, addressing the problem of restricted upgrades. So currently what is being discussed or being worked on is version 1.5 of the Gossip protocol. What will that do? That will allow the usage of P2TR transactions. Okay, using key part signed channel announcements. So those of you who know what Taproot is know that there are two parts through which you can send a P2TR transaction. One is the key part and the other is a script part. So up till now, we have only P2WSH, which is a mechanism that we use, or which is a type of script that we use for commitment transactions and funding transactions. What's being worked on, version 1.5, is to facilitate commitment and funding transactions of the Lightning channel using P2TR outputs, but only P part type. All right. This is being discussed and proposed in version 1.5. A more ambitious proposed upgrade to LN Gossip, sometimes called V2 Gossip, proposes to address both linkability and restricted upgrades by allowing signatures for a broad range of UTXOs to be used, not just UTXOs that match an LN template. This will allow breaking the connection between channels and UTXOs in several ways, including allowing owners of UTXOs to sell non-spending signatures for them to LN node operators who want maximum privacy. It would also allow some non-LN UTXO owners to broadcast fake channel announcements as a part of potential gossip act, but the amount of gossip that could be created would still be limited by the cost to create and hold a UTXO. A version of Gossip V2 was proposed in 2019 with an updated version being proposed in 2020 that allows using a wide range of UTXOs. Concerns about the use of non-LN UTXOs have been debated since then, with Gossip version 1.5 being proposed as a less ambitious alternative. A compromise version called version 1.75 was proposed at the NN developer meeting. So, okay, we discussed what is Gossip version 1. What is 1.5? 1.5 is allowing P2TR outputs. What's V2? V2 is allowing multiple scripts like P2TR and P2WSH and P2 other than that, right? By allowing signatures for a broad range of UTXOs to be used. Okay. So this is what we have to cover about channel announcements, right? We covered what channel announcements are. And to make a channel announcement, you need to sign that channel announcement message with a with the privacy corresponding to a P2SH UTXO. Okay, this has some drawbacks. It restricts upgrades. You cannot use any other type of script other than the P2WSH, and it also has a drawback of linkability, meaning people monitoring the blockchain can gauge what is the use case of this transaction. An upgrade is version 1.5, which allows P2TR transactions, and another update is V2, which allows a broad range, meaning P2WSH and P2TR, and even more than. Okay, so this is what was discussed, and Newton posted to Delving Bitcoin a description of several proposed changes to the new channel announcements protocol that will support advertising simple taproot channels, right? Up till now, you cannot advertise simple taproot channels. Okay, you can only advertise which channels? P2WSH channels, right? Because you need to sign the channel announcement message, and currently, the channel announcement messages can only be signed with a key corresponding to a P2WSH script. So currently, if you're using P2TR transactions to start or end a Lightning channel, you cannot announce it. You have to keep it private, all right? So the discussion involved support for advertising simple taproot channels, meaning allowing channel announcement messages to be signed by the keys corresponding to P2TR transactions, but only the key parts, right? The most significant plan change is to allow the messages to also announce current style P2WSH channels. This will allow nodes to later start switching off the legacy protocol when most of the network seems to have upgraded. All right. So Gossip V1 will be kept in place, and simultaneously the work will be done on allowing public announcements of challenge using P2TR transactions. This is one of the things that was discussed. We'll quickly go through the other two. Another addition recently discussed in newsletter number 325 is to allow announcements to include an SPV proof so that any client that has all of the headers from the most proof of work blockchain can verify that the channel's funding transaction was included in the block. Currently, lightweight clients must download an entire block to perform the same level of verification. Newton, Newton's post also briefly discusses allowing opt-in announcement of existing simple taproot channels due to the current lack of support for announcements of non-P2WS channels. All existing taproot channels are unannounced. A possible feature that can be added to the proposal will allow nodes to signal to their peers that they want to convert an unannounced channel to a public channel. Okay, so there are two things. One discussion is for allowing light clients to verify the presence of a transaction in a block. Okay, because light clients do not have the entire blockchain. Okay, but what light clients can do is that light clients can ascertain the presence of a transaction in a block. Okay, so if somebody is announcing a Lightning channel and they're referencing a UTXO to commence that Lightning channel, the light clients can have the header of the entire blockchain, okay, which is like very small in size, like maybe less than 100 MB. Okay, so the light clients can store the headers of the entire blockchain from the Genesis block to the active chain tip. And when the channel is announced, they can access that specific transaction through a Merkle proof. All right. So you have the hash of the Merkle proof in the block header, and you get the Merkle proof of the transaction which is funding that Lightning channel. Using that Merkle proof and the Merkle proof, you can verify that that transaction belongs to a certain block. All right. So this was discussed that light clients or light group clients that work on resource constrained devices should be allowed to verify the presence of a transaction, whether it's the funding transaction or the commitment transaction in the block by using the Merkle proof and the Merkle group. All right. Now, light clients cannot prevent double spending. Light clients cannot tell you whether that transaction has been spent or no. For that, we need to download the entire blockchain. But light clients, what they can do is they can be sure that a certain transaction existed in the block, meaning it's a valid transaction. Okay. And the third section of the news article is that the allowance of converting an unannounced channel to a public channel. So if somebody already has a P2TR transaction, which is unannounced, we covered just now that you can only announce P2WSH Lightning channels. You cannot announce P2TR Lightning channels. They have to be private. Okay. So if you already have an existing private channel, once P2TR what is enabled via Gossip version 1.75 or 2.4, those channels should be allowed to go public. Correct? You need not discontinue those channels and switch to the public version or discontinue that channel and start another channel. But what you can do is that if the channel is private, it is converted to a public channel. So these were some major discussions that happened, I believe, in the recent summit that happened in Tokyo. That's what my assumption is. To upgrade the channel announcement mechanism pertaining to the Lightning network. If anybody has any questions or anything to share or ask pertaining to the first news article, please go ahead and do so. Mhm. Something in the chat box. Boy knows this copper consumption per minute pretty well, self-awareness, I'll speak. Yeah, I mean, people at Starbucks are staring at me. So anyway, okay. So Anmol is here. Uh, Anmol, you can take over. Anmol will take us through the second news article. I will just announce or read what the title is. The title is Draft Bit for Sending Silent Payments with PSBTs. Anmol is working on a silent payment. Okay, he'll probably introduce his work better, but in brief, he is working on multiple projects pertaining silent payments, and he's the most well-equipped person, I believe, at Bitshala to talk about this. So I requested him to come over and walk us through this depth, and he complied. So he is here. I'll mute myself and Anmol and kindly take over.
Okay. Um, you can just like keep sharing. Yeah, just like scroll a bit so that we can see the entire news. Yeah, thanks. Um, hello guys. So yeah, I'll just like quickly read through the news item and then we can talk more about the item and silent payment in general. So Andrew Tooth posted to the Bitcoin dev mailing list a draft BIP for allowing wallets and signing devices to use PSBTs to coordinate the creation of a silent payment. This continues the previous discussion about an earlier iteration of the draft BIP, see newsletters 304 and 308. So this has been previously being worked upon as well and was mentioned in the earlier newsletters. And as mentioned in those earlier newsletters, a special requirement of silent payments over most other PSPT coordinated transaction is that any change to a not fully signed transaction inputs requires revising the outputs. So this is like something very specific to silent payment that doesn't happen in normal transaction, and we'll talk more about it later when I get into the details. The drought whip only addresses the expected most common situation where a signer has access to the private keys for all inputs in the transaction. For less common situations, for multiple signer tooth wrote that this will be specified in a following BIP. So this BIP basically solves half of the problem. Okay, yeah. So let's start about with talking about silent payment and what it is and why is it even there. So silent payment allows you to basically create a single static address that you can like post it with, like post it on Twitter or like share it with your friends, and they can use that single address to keep sending money to you or tips to you. And then this doesn't actually this is actually very different than using using a same Bitcoin address multiple times. So this silent payment address is not actually a true Bitcoin address. The silent payment address basically encodes the information required to generate an address, and then which can be like detected by the receiver. So this is more in line with how XPubs work, which is like you give someone your extended public key and they can use that to derive like different address which they can use to pay you. So silent payment address is like kind of similar to that, where there's this one static address which has all the information required to like generate an address and then send money to that address. And then the receiver can actually like scan all the transactions and look for a particular like a particular scan key, and then if it's present in the transaction, then yeah, the receiver can generate the private key and then spend those inputs. So yeah, some of the reasons why we have silent payment is that the UX has improved greatly. So imagine being able to store silent payment address in your contacts, and then you never have to ask for a fresh address to that person ever again. You can just like ask them their silent payment address once, store it in your contacts, and then keep paying them multiple times over and over again. Very similar to how like LN addresses work. where there's this like a single static address that can be used to make multiple Lightning payments. And then it's also better for receiver privacy. So like whenever you use silent payment, you generate a fresh address based on the inputs that you use in the transaction. So this means that like each and every silent payment address will be unique, and and any changes in the inputs will result in a completely different silent payment address. So that's basically why we need this BIP, which is being talked about in this news item. Okay. And yeah, and no two silent payments are ever same. It's like cryptographically impossible for them to be the same based on the spec. If you want to like learn more, just like go through the silent payment BIP. It explains it very well. And then yeah, another reason why you want to use silent payment is that you don't require a server setup. So right now, if you want to receive donations, you either use a single static address to receive those donations, which is like very, very bad for privacy because everyone can see your balance, or you use something similar to a BTC Pay server where like you have the server running, which like keeps generating fresh addresses and you use that to receive donations. This is slightly better for privacy, but then the downside is that you have a centralized server which you need to run, and there are like costs associated with that and all that. And then even then, like there are chances of address reuse because people can just like keep paying you to the same address. So yeah. Okay, so yeah, that's about silent payment. Why we need this BIP is because we need the software wallets to be able to communicate with hardware wallets. So whenever like you use a hardware wallet with the open source wallet like Sparrow or something, it like connects to a hardware wallet, and then it actually like transmits a PSBT, and then the hardware wallet signs it and then sends it back, and then you use the Sparrow wallet to like broadcast the transaction. So this like BIP allows users to create a PSBT that can be used to send the silent payment transaction to the hardware wallet, so the hardware wallet can sign, and then once it's signed, the software wallet can use it to like broadcast this transaction. And some of the limitations of this BIP is that multi-party silent payment transactions cannot happen. So if you control all the private keys, then only you can use the specification mentioned in the BIP. Otherwise, you can't. Okay, that's it. Any questions, anyone?
Thanks a lot, Anmol, for walking us through that news article. Any questions? Anybody? Please feel free to unmute yourself and ask the question or put in the chat section. In the meantime, I had a couple of questions. My first question, I think you answered it, is that this is pretty analogous to what we have on the Lightning network, which is Boltfell offers, right? A static address that you can reuse to receive payments from the Lightning network.
Yes, correct.
And one thing that I figured out today was that, I mean, each new signing payment address is, I mean, the signing payment address generation is depends on the inputs, right? So it's not possible for two valid Bitcoin transactions to have the same input, and thus it is not possible for you to use the same signing payment address twice, right?
Yeah, correct.
Okay, all right. And what this BIP does is that this standardizes the communication between the software and the hardware, right? So it becomes easier for people who are building clients that they have to follow a specified a specific predefined mechanism that facilitates communication between multiple software wallets and multiple hardware wallets instead of everybody working in parallel on their own. There's a BIP, there's a protocol, there's a mechanism specified, so you stick to it, which ensures better communication between different hardware wallets and different software clients, right?
Yeah, that is correct. And the reason why this BIP exists is because um like no hardware wallet will like understand silent payment, right? It's just like a software thing. So like
Right.
everything related to silent payment will only happen on Sparrow or like whatever software wallet you use. And the hardware wallet is They're actually just there to like sign the transaction, and that's it. So that's why, like, to bridge this gap, we need this BIP where like you give the right information to this to the hardware wallet so that it can actually like sign the silent payment transaction.
Right, right. Cool. Yeah, these are the questions I had. Thanks for that. Anybody has any questions, any thoughts, anything to ask, anything to share, anything you've heard interesting about silent payments? If no questions, then thanks a lot and more thanks again. If you'd like to stay with us till 9, we'll be more than happy. If you have other commitments, then please feel free to excuse yourself.
Yeah, I need to
Somebody's
drop off.
typing
Like I
sounds.
have something else I'm working on. So yeah, I'll let you guys continue. See you
So,
guys.
if you
Bye.
have a couple of minutes, a question like Agnivo, why is it worth our interest?
What do you mean, like silent payment? Because
Yeah, silent payments. Like as a Bitcoiner, like how is it adding any value to my experience or me as a Bitcoin? How is it making Bitcoin better?
so like it's great for privacy in general. So that's a big plus. And then it's very rare for privacy preserving protocols to also improve UX. So like this is like checks both of those criteria. So it improves UX because you can just like save a static address and then use that over and over again instead of like asking that person for a different address every time. And then it also improves both sender and receiver privacy. So yeah.
Right. Yeah, so you answered Agnivo's question. So, yeah, thanks a lot, Agnivo.
Okay, bye guys. Take care.
Yeah, Agnivo. Agnivo commented and Agnivo himself laughed and Agnivo himself saluted. Oh, all right, we'll move on. Okay, so we'll go to the Bitcoin Stack Exchange question and answer. Okay, I speak a little softly because I'm at a public place. If you guys are not able to hear me, please let me know. Then I'll try and be a bit more loud, but I'll try and be as soft as possible so as to not disturb people around. All right. So the first question: duplicate blocks in BLK.dat files. Peter Wooler explains that in addition to the current best chain of blocks, the block data files can also include sales of the duplicate block data. Let's look at what this question is. All right. So the questioner says, I created a parser and split the entire chain into pieces. When inserting them into a database, to my surprise, there were 187 blocks with the same hashes. So initially, I thought that there was something wrong with what I was doing, but after debugging, I found duplicates inside the blockchain. I only investigated one. I only investigated one block with the hash. This was the hash. I found the same block in two different .dat files. Okay, so this is one .dat file. This is the second .dat file. I know for sure that the two blocks are identical because I split both .dat files into blocks and compared the hashes. The first one has the height 772,553 and the second 772,776. Is this normal? All right. So what is BLK.dat file? Okay. So basically, if you've ever run a Bitcoin node, when you sync your Bitcoin node with the blockchain, that blockchain or the data of that blockchain is stored on your node. Okay. Now the entire blockchain is not stored in one file. Okay. So what data is stored? Data pertaining the block. All right. So the information in the block data and the transactions, all of these things are stored on your node. Why to validate transactions, right? That is why we call it a full node. It is a full node because it stores the entire blockchain and it can validate transactions in and of itself. Now, where is this information stored? It is stored in file or a series of files which are named as this blk.dat, all right? And there are a lot of files like blk0336 blk0336 We'll have lots of such files, right? These are not human readable files. If you open these files in a text editor, you'll not understand what it is saying. These files are in binary form. Okay, you have to pass them. You have to use the parser, and the parser converts it into a human readable file. So what do these files have? These files have information pertaining the block. As you can say, BLK corresponds to the block. So they have the transactions in the block, they have the block header, all the information pertaining the blockchain that you need to validate a transaction. Your node stores all of that information. Okay, now not all the information is stored in one file, right? Like somebody might ask a question like, why do we need multiple files? Why do we store the entire blockchain from the Genesis block to the active chain tip in one file? Why do we need so many .dat files, right? So what happens is that the data of the blockchain from the Genesis block to the active chain tip is bifurcated and split across multiple .dat files. The reason being, it's not necessary that you want to download the entire blockchain, right? It might also be possible that you only want to retrieve the information of certain blocks, right? You don't want to retrieve the information of the entire blockchain. For some use case, you are running a node where you only want to store data from block X to block Y. So you will only access files that are specific to those blocks and retrieve information from that. All right. So that is one of the reasons why the entire blockchain data is not stored into one file. Rather, it is bifurcated and scattered across multiple files. If you need to store the entire blockchain or retrieve data of the entire blockchain, then you can use all of those files. But if you're only interested in a subset of data, then you can only access files that correspond to that subset. Okay. Now, if you're running a Bitcoin Core node or any of its folks, what happens is that there is an inbuilt parser. You can use your terminal to parse these files, okay, and they will convert the information in these files into human readable format. All right. Now it is also possible because of the reorg, for instance, that two different files might have the same block. Okay, two different files might have the same block. So there might be a block which is a part of the blockchain. Okay, and then that block is stored in your blk.dat file, and then a reorganization happens. But even on the computing chain, that block also exists. It's possible for same block to exist in two competing chains, right? So in that situation, it is possible that your blk.dat file or multiple blk.dat file will show the same block because of a reorg, for instance. Okay, so what this questioner asks is that he passed all of his blk.dat files, but he passed them on his own, right? He used his own password. He did not use the inbuilt password in Bitcoin Core, and he noticed that there were 187 blocks with the same hashes. There were 187 blocks with the same hashes, but ironically, those blocks had different heights. Okay, so he assumed that these are different blocks because if the blocks have same hashes, it means it's the same block, right? If two blocks on the Bitcoin blockchain have same hashes, then they will have same height because they are the same block essentially. But he noticed that he came across blocks that had the same hashes, but they had different heights, and he was confused. How is it possible? Like, how is it possible for two blocks, two different blocks of Bitcoin, to have exactly the same identical data because they have different heights, right? So the answer is it is perfectly possible that same block is stored twice in Bitcoin Core blk.dat files. There is no guarantee that the files contain the blocks in sequential order or continuously, and unused space may exist in them, which contains parts of blocks as well from the active chain of failed blocks. Bitcoin Core maintains an index of where which block is to be found on this. If you pass things yourself, you will need to figure out the relation between all the blocks we find and determine which ones are valid. Since every block contains a hash of its parent, if you see the same block data twice, it is necessarily the same block at the same height. The answer is that these are essentially the same block. These are not two different blocks at two different heights with the same hash. These are the same blocks at the same block height. Why is the questioner observing this that there are blocks with same hashes at different heights? Because he is passing that information himself. He's passing that information himself, and it was the parser that he is using that is giving him erroneous output. Okay, if he would have used the inbuilt parser of Bitcoin Core, which is trained and designed in a manner to retrieve information properly, this will not have happened. All right. So if you see two blocks on the Bitcoin blockchain with the same hash, okay, then they are the same blocks. And if you use the inbuilt parser, then you will find the same block height as well. Okay. So the questioner found different heights for same hashes because the questioner was using his own parser and not the inbuilt parser, which knows how to handle the indexing. So this is what the question was about. There are blk.dat files on your node, which stores the information pertaining the blockchain, the block headers, and all the transactions from the block, which is used for transaction validation. This information is converted into binary format to compress the data and scattered across multiple blk.dat files. Okay, and then there are inbuilt processes in Bitcoin core work them into human readable format, and this questioner was trying to do this, was trying to pass this information with his own parser, and that is why the parser was not able to appropriately handle the information, and the parser considered the same block to be two different blocks. So the parser was showing the same hash but with two different block height, which is incorrect. Had he used the inbuilt parser of Bitcoin Core, he would have come to the inference that two blocks with the same hash will always be the same block and have the same block height. All right, this is the first question. If there is anything that you want to ask, please unmute yourself and feel free to speak. Because after every question, I won't stop and wait for people to ask. Right, I'll proceed. If you have anything to ask, just feel free to interrupt, mute yourself, and ask the question. And if there's anything in the chat, then I will check the chat. Yeah, Cody. Yeah, thanks for sharing. Oh, yeah, we have 13 more minutes. So let's see. Next question. How was the structure of pay-to-anchor decided? Anchor console describes the structure of the pay-to-anchor P2A outputs included as part of Bitcoin 428.0 policy changes. The best 3210 included 2 byte length version 1 with this program was chosen as DC1 P raw GF vanity address. Okay, so we talked about what pay to anchors are, and I think we also covered a PR review in the Optech session pertaining to pay to anchors. Right. So let's just look into the question. The questioner says, I'm trying to understand the new pay-to-anchor script, which is part of version 28.0. Here's the script definition. As I understand, the above script would translate to up to push data code 24873. Can someone please confirm that this is the correct understanding? Also, what's the reason for this particular script for pay-to-anchor? It appears that it is not a validated. Okay. So before this, let us try and understand what a pay to anchor is. Okay, let's read this. So ephemeral anchors are a proposal to allow some transactions to be delayed even if they don't pay any transaction fee, provided they're delayed as a part of a package containing a child transaction which pays the fee sufficient for the entire package. So ephemeral anchors, okay, basically these are outputs. These are zero value outputs that pay to an opt-to script. All right. Now, because these are obviously zero value outputs, nobody will relay them. Okay. Now, what do you have to do? How do you relay them? You relay them with a child. So there is a child that pays a higher fee. Why are they used? Okay, they can be used at multiple places. One use case could be the Lightning Network, and we've talked about this on multiple occasions. What a pinning attack is, all right? So to mitigate a pinning attack, you can have an ephemeral anchor, okay, a zero value, a zero output transaction pinned to your commitment transaction. So your commitment transaction can have an ephemeral anchor, meaning a zero value UTXO. And the only reason for that zero value UTXO to exist is that because in the Lightning channel, we cannot predict the fee of the commitment transaction. So we have a zero value output attached. And when we want to broadcast the commitment transaction to the main net, at that time, we attach a child. At that time, you attach a child and bump the fee and then broadcast the commitment transaction. So, only purpose of this ephemeral anchor, for instance, in a Lightning network could be to attach a child and mitigate pinning attack. The proposal is built on top of V3 transaction relay proposal. A V3 transaction containing as little as zero fee that has zero value output paying up to as the entire script would be accepted when included in a relay package with a fee paying child. All right. So this ephemeral anchor could be a V3 output, and we talked about them in detail. So a V3 output can have only one part. An unconfirmed V3 transaction can have only one unconfirmed V3 child. Okay, so to a Lightning channel commitment transaction, you can attach an ephemeral anchor, which basically has zero value, which pays zero fee. But then you attach it with a child that pays a fee, and then you relay that package as a package relay to mitigate pinning attack. All right, and the script that is used for the ephemeral anchor is known as P2A script. Is known as it's known as pay to anchor script. Okay, so how does that script look? That script basically looks like this. Okay, that script looks like this. So it basically means op1. What is op1? Op1 basically signifies version one. Okay, it signifies version one, segwit version one, because we have two versions of segwit version zero and segwit version one. So op1 signifies segwit version zero. Okay, this, and then it has this, which indicates that the data that follows is going to be 2 bytes. So this 051, this is op1. Okay, this indicates the data which is 2 bytes. Okay, so in segwit version 0, the script can be of 20 bytes or 32 bytes, right? So if the script is a P2SH, a P2WSH script, it's 20 bytes, and if it's P2WPKH script, then it's 32 bytes. Okay, but for version 1, for segwit version 1, there is no such limitation. Script can be of any size, but it should be above 2 bytes. Okay, since these pay to anchors are, you don't need a key to spend them. Okay, they are paid by opto, like anybody can redeem them, because obviously it's zero value, so there's no incentive in anybody to try and steal them. Okay, and because we don't need any keys to access these anchor outputs, we try to keep the script as minimal as possible. Okay, which is bare minimum, which is 2 bytes. So we just need a script for the sake of it. So this first byte of the script, okay, will indicate that it is segment version one. This of the script, this section of the script will indicate that the data that follows is 2 bytes, and this is that 2 bytes. Okay, and this 2 bytes, when converted into human readable format, comes up to this. Fees. It just means fees. Okay, so it's just a fancy way. I'm sure those of you who have studied mastering Bitcoin know what a vanity address is. Like you can create a vanity address with your own name, okay, or like I love XYZ, whatever. Okay, so these addresses, like we have, people who pay a lot of money for fancy mobile phone numbers, or people who pay a lot of money for fancy car number plates. Okay, so we have something known as vanity address, where you can use certain algorithm to create a a Bitcoin address, which could be reputation of a number, or I love you, or somebody's birth date, or something like that. So if you all get time later on, just explore what vanity addresses are. So this is just a way of creating a vanity address. Okay. So the questioner asks, what is the reason that this specific script is choose for pay to anchor output? So the answer is that this indicates that this script is of version one, segment version one, meaning it is not bound to being 20 bytes or 32 bytes, right? It can be anything but greater than 2 bytes. And then this indicates that the data that was following is 2 bytes. And then these are those 2 bytes, which when converted into human readable format, this one here, okay, they turn into this address. BC12 P raw GF. Okay, it's just a vanity address because this includes fees. This includes fees, which means that you are going to attach a child to this transaction, and that child is going to pay the fees of the parent. So it's just a fancy way of creating that script. So this is what the question was, and this is the answer is. So now we know what are ephemeral anchors, and what is the pay to anchor script, and why does the pay to anchor script look the way it look, and what does it indicate? I think let's take one more. We're at 8:55. So what are the benefits of decoy packets in 5024? Peter Muller outlines the design decisions around the inclusion of decoy packets in the BIP 324 specification. The optional decoy packets can be used to obfuscate traffic patterns to prevent recognition by observers during the key exchange, application, and version negotiation phases of the protocol. Okay. First, let us in brief talk about what BIP 324 is. Okay, so what BIP 324 does is that it encrypts the information that is passed on the Bitcoin network. Okay, so up till now, what was happening is that all the messages that were being transmitted between nodes on the Bitcoin network were being transmitted in plain text. So anybody could intercept those messages and access those messages, right? So if two nodes on the Bitcoin network are communicating with each other, anybody can intersect that communication and exactly see what those two nodes are saying to each other. What BIP 324 does is that it introduces a new version protocol for communication between nodes. So it's known as V2 protocol, where when two nodes on the Bitcoin network communicate with each other, the communication between them is encrypted. So even if somebody tries to intercept their communication and tries to decipher that message that they are transmitting among each other, all they will see is some mumbo jumbo. all they will say is some mumbo jumbo. Now there are some other enhancements as well, reduction in latency and reduced bandwidth consumption. But primarily when you talk about BIP 324, you talk about version 2 or transport, which is where the information that is being communicated between nodes is now encrypted. Okay. Now there is this another thing that is being talked about in this question, which is known as decoy packets. Okay. So if I had to explain in a layman's language, what are decoy packets? Basically, decoy packets are packets of information that are broadcasted in a network just to make heuristics and monitoring more difficult. Okay. Now, if I had to explain it in a layman's language, if I want to send an envelope to anybody, okay, so let me choose some person. Okay, let's say Saurabh. Okay, if I want to send an envelope, if I want to send a letter to Saurabh, okay, what I can do is I can just put that letter in an envelope and send to Saurabh, right? Now, when somebody sees that one letter is going from Faisal to Saurabh, they know that there is some important information in that. They can intercept that envelope and they can try and access what information is being sent in that letter. But what if I like make five envelopes? Okay, I make five envelopes, and in one of those five envelopes, the actual letter is there, and in the other four envelopes, I just write some gibberish, some mumbo jumbo, and I put it in an envelope, and I send those five envelopes one after the other. So a person who is trying to intercept our communication will now have more work to do because there are five envelopes, and they don't know out of those five envelopes, which is the actual envelope in which I'm sending the information, right? So it basically makes it even more difficult for them to intercept the communication between two people. So these are what default packets is. People who are experts in heuristics, what they do is they monitor the network and they see certain patterns. Depending on those patterns, they can analyze what information is being shared, right? Even if that information is encrypted, it is possible for people who possess expertise in heuristics to gauge what that information is. Like in this session itself, we saw an example that it is possible for somebody to monitor the blockchain and figure out that a transaction is a funding transaction of the Lightning channel or it's a commitment transaction of the Lightning channel. How do they know that? Whenever they see a P2WSH script from a 2 of 2 multi-sig account, it is a very strong hint that this transaction is funding a Lightning channel or it's a commitment transaction of Lightning channel, right? So people use such information, right? So if they see a version, if they see a handshake message between two nodes, they can analyze it based on the size or the frequency or the time at which that message is sent, right? So even if a message is encrypted, it is possible for people to analyze the frequency of that message, the timing of that message, the size of that message, the attributes of that message, and infer what that message could be. Okay. Now, what decoy packets do is that decoy packets are basically dummy messages that you broadcast on the network to camouflage the actual message. So, if you are sending a version a sharing message, okay, a version acknowledgement message or a version sharing message with another node, what you can do is that you can precede or proceed that information with decoy packets. So, if I want to do a handshake with a node, for instance, okay, now, if I just send one message to that node with which is my version message, and they share another message with me, which is version acknowledgement message, it's possible for somebody to infer that okay, these two messages were exchanged between two nodes. They might be the version message and version acknowledgement message. But what if I before sending the version message, I send two three decoy packets, and after sending the version message, I send two three decoy packets. So I'm sending six seven messages. Now it becomes very difficult for a person who is analyzing the network to figure out that I'm actually sending a version message, right? Because I'm not sending just one message, I'm sending six, seven messages. But five or six of those messages are just decoy packets with gibberish data, and one of them is the actual message which I intend to send to the recipient. All right, that is what decoy packets do. That when you want to exchange information on a monitored network, and it is possible for somebody who's monitoring that network to infer what that message is about to use decoy packets. So you send lots of messages before and after that specific message, which look and resemble that message. So it becomes very difficult for the person who's trying to intercept to figure out what exact information is being shared, right? Just like I gave an example that if one person gives an envelope to the other person, it's very easy to intercept that envelope. But what if I send five, six envelopes? All right, and all of them have gibberish information, only one envelope has actual information, then it makes their task even more difficult because now they don't know what like which among these five or six messages actually have some relevant information. So that's what decoy packets are. And that's what BIP324 also does. Okay. So along with the encryption, it also incorporates decoy packets. So whenever there's a handshake message or different messages are exchanged between two nodes on the network, they are preceded or proceeded by decoy packets, so that the information that is being shared cannot be inferred by the frequency or the time or the size, even if it's encrypted. Okay. So I'll just go to the answer in brief. The goal of decoy packets in general is offering the option to implementations of hiding any pattern that can be inferred from the sizes of TCP/IP packets being sent back and forth. Right. So just like I said, that with 324, what does it do? It encrypts the information. Okay. So if I'm sending a version message and my the other node is sending a version acknowledged message, maybe the version message is of a specific size, or the version acknowledgement message is of a specific size, or the time frequency between a version message and a version acknowledgement message is a certain few seconds, right? So people who are monitoring the blockchain can use these parameters to infer that this is a version message and a version acknowledgement message. But what if I send decoy packets, okay, a few messages before that and a few messages after that, then it becomes very difficult to realize that pattern for what exact information is there processed, right? So this is the goal of decoy packets. The goal of decoy packets in general is offering the option to implementations of hiding any pattern that can be inferred from the sizes of TCP IP packets being sent back and forth. We'll not read the entire thing, it's pretty long, but this concern applies to all three phases of the protocol during key exchange. Okay, so the first phase is when you exchange the key. Okay, the key exchange phase between two nodes. Hiding can be accomplished through the garbage mechanism. There is another mechanism which is known as garbage mechanism. What is garbage mechanism? You fill the messages that you share with your peers with garbage, so that all the messages are of the same size, right? So let's say there is a version message which is of a specific size. There's a version acknowledgement message that is of a specific size, and there's some you're relaying a block which is of specific size, you're relaying a transaction which is of specific size. So these sizes can be used to infer what information you are sharing, even if it is encrypted. But if you fill them with garbage and ensure that all the messages that are being shared on the network, okay, garbage is also known as padding. So, okay, so all the information that is being shared on the peer-to-peer network is all of the same size. So nobody can infer using sizes that what information is being shared. So this is also one of the mechanisms that is used, which is known as garbage mechanism, but decoy packets is different during the application phase, but also during the version negotiation phase. This is done using decoy packets, a much more powerful mechanism than garbage, but only possible after keys have been exchanged. Okay, so basically, you need decoy packets at three stages: the exchange phase, okay, application phase, and version negotiation phase. These are the three important phases between two nodes that communicate on the peer-to-peer network, where you want utmost level of privacy, encryption, and obfuscation, which can be achieved during decoy packets. So the questioner asked, is it not difficult, like implementing these decoy packets, is it not really difficult for people who are building clients in Bitcoin? And the answer in just says that yes, it is difficult to do so. And secondly, the questioner asked that there is no specification for the size of the decoy packets, like how big can a decoy packet be? The answer is that the decoy packet can maximum be of 4 MB. Okay, so 4 MB. Why 4 MB? Because the biggest message that two nodes can exchange with each other currently on the Bitcoin network is 4 MB. Why? Because that's the size of a block. So if one node is sharing a block, launching a block with peers, then that message will be of 4 MB. Okay, so the highest size or the maximum size of the message that can be exchanged between two peers on the Bitcoin network currently is 4 MB, and that is why the size of the decoy packet is also restricted to 4 MB. So this is what decoy packets are. This is what they do. This is what the use cases in context to BIP 324, and they are primarily used, or they can be primarily used at three stages, which are the handshake, version negotiation, and the application phase. And their size is restricted to 4 MB. This is the third question, which is all that we'll be able to cover today. You all are free to go through the other questions. They're very interesting. And if you have any follow-up questions, please feel free to ask them on Discord or maybe next week. And we'll try our best to help you out. That is all that I had to share for this session. If you all have any questions, anything to share, please go ahead and do so. And if nobody has anything to share, then please feel free to sign off. I'm done from my end. Nothing, no questions.
None from my side. Thank you, Fazil.